it's fighting the negative 1,000 newton meters, what does it have to do? The truss is not moving at all. 1,000. Has to be 1,000, right? So the moment here also has to be 1,000. So moment at C has to be 1,000 newton meters. Positive or negative? Positive. It's got to cancel out the negative. It's got to be positive. All right, that's cool, but that didn't actually solve RCY. How do I get RCY from that?
Wasn't RCY just same as 100 newtons? So
Why?
because it's preventing the thing from spinning.
Okay, so it's preventing the thing from spinning. So my moment here is still force times distance, right? And moment was 1,000 newton meters is force times distance. And what's the distance? What is this perpendicular to? AC, right? 10 meters. It's perpendicular to that. So I'll replace distance with 10. Divide both sides by 10. And force is 100 newtons. Okay? Now the cool thing is that's RCY, right? RCY is 100 newtons. I'll put it over here. RCY is 100 newtons. Questions so far? The whole reason we do that is just to solve RCY or RAY, so get one of those. Really, we just need one, and we're in good shape. Okay, we got one, we got RCY, awesome. Now, we can sort of abandon moments for the rest of the problem. We don't have to worry about moments again, we don't have to say the word moment, just to break our way into the problem. There we go. So step 2 is what we call external forces. Okay? External forces. And what that means is if you imagine the entire truss as like a dot, let's do a free body diagram for it. What is acting on this truss? What forces are acting on this truss? Thompson, you want to offer something? What force is acting? You do one force is acting on this.
100 newtons.
That's the same answer. You're both correct. The 100 newtons kind of is encapsulated in gravity. Okay? And when we get into like high-end analysis of this, we have to work out the weight of the truss and everything else. But right now, we would just say, okay, here's a force that's acting. Okay? So we'd say 100 newtons is there. Okay. If that's the only force on this truss, it is rocketing towards the center of the Earth. So what else is acting on this truss? RCY, sure. RCY. What else is acting on this truss? RAY. What else is acting on this truss? RAX. Okay, that's it. Those are all the things that are acting on this truss. Are there internal forces inside those members? Sure, but we're not talking about that right now. This is external forces, so we only deal with what's happening outside of the truss. Because now I can solve some things. You're going to see me write this a lot. Sum of forces. Sum of forces in the x direction must equal 0. The sum of forces in the y direction must equal 0. Over here we did the sum of moments must equal 0. Okay, so start with y. What is acting in the y direction on this truss? What's acting in the y direction? We wrote them up there. RAY, agreed. Is RAY positive or negative? I don't know the number yet. But looking at that, is RAY positive or negative? Okay, right now we're saying it's positive y. It's going up. Okay, now be careful. A moment ago we were talking about clockwise, counterclockwise means positive and negative. That's for moments. Now we're talking external forces. We're back to that coordinate system. Up is positive, down is negative. To the right is positive, to the left is negative. Okay? So RAY is positive, so I'll leave it positive. Okay, what else is acting in the y direction? RCY, sure. Positive or negative? Positive, because it's going up, right? So plus RCY. What else is acting in the y direction? 100 newtons, positive or negative? Negative, why? Okay, so it's going down, so we would say minus 100 newtons. And this whole thing, there's nothing else acting in the y direction, right? This whole thing must equal 0. I'm going to add 100 to both sides just to kind of get these variables on their own. Just cross out. So now I'm left with RAY plus RCY equals 100 newtons. Do I know anything else about that? Do I know any of those variables? Do I know RAY or RCY? Oh, I do. I know RCY, don't I? So I'll sub in what I know. Here's RAY plus 100 equals 100. So if I subtract 100 from both sides, 100 minus 100, I have RAY equals 0. There's 0 force on RAY. Will there always be 0 force on RAY? No. It just depends on the truss you do. Okay, and what's going on in the truss. Here, because all my force is over here, turns out there's no force on RAY. No big deal. Okay. I'm not done though. I mean, I'm done with Y. What about X? What's acting in the X direction? RAX. So I got RAX. Is RAX positive or negative? Why? Going to the right. So it's positive. Good. What else is acting in the X direction? What else is acting in the X direction? Be brave. What else is acting in the X direction? Say nothing. Nothing. There's nothing else acting in the X direction. That's it. So positive RAX then equals 0. Remember I said way back that statics were great because there's a lot of adding up to 0? Makes the math a lot easier? That's awesome. Since this is the only thing acting in the X direction, we know that it has to be 0. Has to be. That's it. we feeling? So far so good? Okay. So I started with that one, it's a little bit easier, okay, and I took it to external forces. The next step, we're not going to do on this truss, but on the next step what we'll do is we'll go to internal forces. We'll start looking at the actual members themselves. Now this particular truss is going to be super boring internally, okay? Super boring, because there's going to be no force on this member, no force on this member, and no force on this member. This truss is essentially pretty useless, because I only have 100 newtons here, I'm supporting 100 newtons there, so really there's nothing going on in the rest of this truss. Okay? Pretty boring. But a good way to start is the math is pretty straightforward. You with me so far? Alright, so we're going to take the exact same truss here, but we're just going to move this force. We're going to do something a little bit different. Okay, so you want to start this as a new spot in your notes, the next problem in your notes. Okay, we'll leave everything else the same, but we'll put the 100 newtons here. Now I'm actually involving the rest of the truss. All right, I'm going to put the 100 newtons there. I'm going to erase some of our work here. Keep those there. These. Okay. I guess first question, is the truss still statically determinate? How many joints does it have? 3. I didn't change anything, right? So it still has 3 joints. How many members does it have? Still 3. How many reaction forces does it have? 3. So 2 times 3 is 6, 3 plus 3 is 6, it's still statically determined. I didn't mess that up at all, just by moving that force. Okay? So, still statically determinate, we can still solve it. Alright, moment time. Okay. So, now, I'm looking